Today we'll be talking about the information search and data visualization. Let's look at some terminology to start with. So, terminology about information search. For example, finding email address of specific person, or what are the sonnets by Shakespeare? So these will be things that we can search for on a search engine. For example, is there new work in process published by the IEEE, for example? So we could search for this kind of information on a search engine, and we would like to see how this works. So if we come to a search engine or to a website that has search functionality, we can go in there and type our keyword into the search field, and we would obtain some results. Now, there is a lot that happens in the background once we enter that keyword into the search engine and press enter. First of all, the formulation happens as a phase of the search, expressing what the search is. Then initiation of action, launching the search, reviewing the results, the messages and the outcomes, and refinement such as formulating the next steps. Now, if we would be searching on a search engine, the search engine has to search through a vast amount of web pages in order to return us the results, the top results of what our query is. So search engine searches through large amount of websites in order to return the best or the top result for our keyword. So the search engine, in order to do this, it has to look through the graph. So we're talking about large graph processing, because the web pages, the way the search engine sees them as a big graph, because the web pages contain links, right? Hyperlinks to other pages, and the search engine uses these links information to determine the top result. That is, pages are ranked using their links. So because of that, the search engine has to see the collection of pages as a graph. Collection of all pages on the web is seen as a graph. As you can imagine, This is a very big graph that contains all of the web pages in the world. So the search, every time we go to Google and type some keyword in there, it has to look through the entire graph of all the pages that exist to give us the best result, and then it gives the top 5 or 10 pages that will be best answer to our query. And what we mean by best is the ones that are most relevant, right, to our query. And the way that it determines them is by using these links, because the more links point to a specific page, the more important or the more credible this page is, according to the search engine. So that's why it is using those links to rank the pages. And so it has to look through all the pages in the world. That's why Google and most search engines are having to deal with the issue of large graph processing or big data analytics. So you can't just search through all the pages in the world on your laptop. Maybe you can, but it'll take you a couple of days to return the query result, you see, because there is just a lot of pages to search through. So Google and Facebook was one of the first to face the big data problem. Like Facebook is having the same thing. It doesn't have to search through a web pages, but it has to search through another graph, the graph of all the friends on Facebook. One friend is pointing to another friend. It has a link from one friend to another, so again it is a huge graph. Both the Google and the Facebook are dealing with a huge graph search. So the Google has the graph of all the pages and the links between them, and the Facebook has the graph of all the friends and the links between them, who is friends with who. And then the Facebook has to search through texts, like text messages and pictures, right? And pictures and videos. Again, it has the big data problem. Because people every day are posting thousands and millions of pictures and texts to their friends and family as we speak. So the Facebook has found itself in a position of having to search through all of that stuff. If you try to search for something on Facebook, it has to look through all of these data. And believe it or not, the Facebook does not delete anything. It saves all the data and it pretends that it owns it even. So of course it has to follow like certain privacy international laws and stuff. That's why I will ask you, are you in India, are you in the United States, or are you in the European Union? Because there are certain privacy laws it needs to follow, but it still owns the data. and it keeps all of that data. Why? Because, hey, Facebook is a free service. How can it be a free service when it has to search through such a big data? Somebody has to save all this data in computer hardwares and have computer administrators to take backups and make sure it's all functioning correctly. And then it does all this big data analytics and returns the results and maintains millions of users around the world. How can this be free? Well, it's because it makes money from the advertisements, right? So that's why it owns the data, so that he can profile users. Let's say Angelina is 5 feet and 8 inches tall, and she wears a shoe size 10, and she has all of these friends that she went out drinking last night and took all these party pictures, and then she went to visit Canada this day, and the other day went to Europe, and then this is her new boyfriend, and all of that information is stored. And once they know this information, hey, they can advertise shoes to Angelina, or they can advertise trips to Canada to Angelina. So all those advertisers and companies trying to sell shoes or trips to Canada will know that Angelina is likely to buy this service. So then the Facebook is making money from selling the information to advertisers and to advertising, doing advertisements itself. Google is doing the same thing. Okay? How is Google going to be free when it's maintaining such large databases? It has to analyze them. So this is the situation. So how they're gonna search through this big graph? There is specific algorithm that allows to traverse the graph and find the best results, and there are specific mathematical formula for determining the page rank of the pages. So then it returns the best top 10 or 15 pages that we are willing to browse through. So that's the situation in the search engine. Now let's look at searching databases and text databases, relational databases, and databases containing texts. So what are we gonna do to search these databases? This is easy because we are just going to send a query to the database. That's what database is for. Is a database management system that stores the data. That is, it can save, delete, update, retrieve records that are inside of this database management system. And the user can interact with the database management system by sending queries. For example, select star from table named students or from employees. Select star, it means it will return all the records from this particular table. So through this kind of queries, we can generate reports, we can combine tables together, we can search for specific things, like give me all the students of age bigger than 25, for example. So we can run reports like this easily with these queries. if it is a relational database management system. Now, if it is a text, if it is a database of texts, documents, then it is no longer a relational database system, because relational means that it has it's in the form of a table, and it has rows and columns. So we're talking here about relational database system. It has rows and columns, and on the rows the records are sitting, and on the columns are the descriptions of these records. So let's say students are on the rows, and on the columns we have age of students, degree of students, master's, bachelor's, is it in computer science or information systems, or other descriptions, their zip code, their address, their nationality, their color of their eyes, and their marital status. All of these things are descriptions of the records. So properties of the records. So the properties or attributes of the records would be sitting on the columns of this relational database or table. And it's called relational because there are relations between the tables in the database. That is, it contains more than one table, and they're related to each other. For example, students in one table, professors in another table. So that is the relation between the students a particular professor has, right? So professor can point towards multiple students. Or there can be table of classes. So these particular students point to a specific class. So there is a relationship between them. Now, if we're going to be searching text documents, these are no longer relational databases. These are called unstructured databases because they don't have rows and columns like this, right? There are no records on the rows and there are descriptions on the columns. You just got a bunch of text. So how in the world are we going to search something like that? Well, we can search the text for certain texts, certain words, certain strings into the text, right? We can search that. But if we want to do anything more complex than that, we could extract from the text properties. So, and build an actual relational database. Where did it go? There it is. If we want to, we can do the same with websites. We can extract attributes or descriptions, also called features, from the text and build a table or relational database. If we want to do something more, some sort of more complex analytics from these texts, we can do this. So, for example, we can search the web pages and their texts, right? They're HTML pages, they're texts. We can search through them and, let's say, categorize them. All these web pages talk about food and cooking, and these contain pizzas in them, for example. So these web pages are categorized as containing the word pizza, or they are related about cooking and cooking recipes. Then we have all these pages here that are related to computer science and master degree in computer science and education. So then we have another category. And we have over here recreational pages, traveling to nature or traveling to beaches. And so they contain the word beach in them. So we could extract this kind of information and build a table from these texts. Another thing that is oftentimes done with texts is to search for repeating words. So this text contains the word Mike 5 times or 10 times. Then it contains Nancy 3 times or Oscar 7 times. And so on. We could do this kind of analytics doing a word count to determine what is the most popular word into this text file, and then it tells us really what it's talking about. Okay. Okay, let's see what is next here. So text documents and database queuing. So as we mentioned, another thing we can do with text documents is counting the number of specific words into these text documents. This allows us to determine what subject is contained in this text. So this is most frequently occurring word in this text. Another visualization really of this would be, does anybody know what would be visualization of the most frequently occurring word? If we want to visualize the most frequently occurring word, what do you think?
Why, what, how?
Yeah, we could do something like a word cloud, right? A word cloud. I'm gonna show you one word cloud, right? Let me see if I can find one here. There you go. See? The most frequently occurring word will be shown with the biggest size. So big data is happening the most in this text. The next one is information, then resources, then database.
Professor, we can't see you.
Oh, wait a minute. Let me share this. So this is a word cloud right here. If you can.
Yeah, we could see that.
So basically the most frequently occurring word will be with the biggest font and sometimes in specific colors. And so for example here the biggest word is big data, then you have information, intelligence, management, network, and so on. So that would be a visualization of a word count, right? The most frequently occurring word. Let's call the word cloud. So searching text documents, here's another text that has been formatted to show certain fonts and colors on it. So we can do this just through the HTML. There is also certain software, like what we see here, that would allow us to process texts and search through the texts. So this is called a work list filter. So he can search for specific texts into a text document. And this one is a medical record search. So it is searching for inpatient, outpatient, remittance player, variance amount. So there are some healthcare terminology in here. Now, if we want to search for a specific picture or search through images, search engines would allow us to search for those as well. So most systems would allow to locate pictures as well as video, sound, and animation. Those can be searched in much in the same way as the text files, because we would have the same situation if there are texts and videos. We can extract certain attributes or features from these images, and then same thing, place them in a relational database. Example, what colors it has, what objects are on the picture, and then save those into a relational database that will allow us to easily search and index those pictures. Same situations with sounds. We can extract the information from the sounds. What is this sound? Is it a male or a female voice? Is it singing? Is it music? If it is music, does it contain specific musical instruments like guitars and drums and violins? Or otherwise, what is on this sound? And we can extract this kind of information, save it in the database, index it, and then easily search through those sounds. Once this indexing is done, photos can be organized into albums or collections based on who took these pictures, where they were taken, so location of where the picture was taken can be stored. What is on the picture? Is it sunsets, pink clouds? What is it showing there? So we can group them in this way. We can search the sounds and the videos much in the same way. Videos are just a sequence of pictures, right? that are played fast enough so that they appear to the human eye as a motion picture, but in reality they are just a collection of pictures, the videos. So we can search them just the same as we search the pictures one by one and index them. We can build databases. So the videos are a collection of pictures we can analyze them to determine what colors, objects, theme is on the video, and builds a relational database table and index it. That would easily allow us to search through those videos. This would also allow us to do more complex analytics. For example, a video recommendation system. Let's say some new customer comes to us and wants us to recommend them a video that they will like. Right? We can compare this customer to similar customers, see what videos they like, and recommend those to him. Right? So these are some more advanced things that we can do with these videos systems. Okay, so if we are to search on search engine for a specific keyword, you would notice that on top of the screen, the search engine would return first the pages, right, that we wanted to see. And then it has another tab called images that would return pictures related to the keyword. So Google will do this, will return us both websites and pictures related to this keyword. So for example, this one was a hurricane, El Nino, and it returned all these pictures of this hurricane, where it came. These are meteorological weather forecast pictures, and some pictures of what happened to the cities when they were struck by this hurricane. Other searches could be done on emails. we receive lots of emails every day. Emails are just texts, they would be searched the same way as regular text. Okay, so that is what we have today for information search and information visualization.